Hey guys, this is Mr. Pilla here. Today is Thursday, April 16th, 2020, and today we are going to be talking about the human population, alright? We are going to study the human population today. Now, before we get started, there's a lot of information in this set of notes today. It is going to take some time to get through this video, so please make sure that you are paying attention. Please make sure that if you have any parts that you need to replay because you didn't understand something, please do that. And if you have any questions while watching this video, or by the end of this video you have any questions, please get in contact with me so that way I can answer any questions you might have. Alright? Let's get started. And we're going to start here with this idea that the human population has been exponentially growing since the 1800s. And not even really the early 1800s, more so the late 1800s. And I have a graph on the next slide I'm going to show you that represents this. And we talked about what exponential growth is before. We mentioned that exponential growth is just really fast growth, okay? So the human population has been growing very fast since the late 1800s. And what is the population at this point? What is the size of the human population at this point? And right now, the human population is at 7.8 billion people. Just to give you an idea of how fast the population is growing, when I was in high school about 10 years ago, the population was around 6 billion people. It was in the 6 billions. I don't exactly remember the number. I just know that it was in the 6 billions. So in the last 10 years, the population has jumped at least a billion people. That is insane how fast that growth is, to be able to jump at least a billion people within 10 years. And the big question is, can the Earth sustain this growth? And to be honest, the answer is no. Reason being is that we've talked about the idea of carrying capacity before, where any population within an ecosystem is going to have a max population size based off of the resources available within that ecosystem. And humans are no different. Humans have a carrying capacity for this planet. Now, we don't exactly know what the population size is for that carrying capacity. We don't exactly have a number linked to it, but there is going to be a carrying capacity for humans on this planet, okay? And if you take a look at this graph here, again, this graph represents the human population over time, so it represents the world population over time. Our y-axis here is the population size in billions, so this one represents 1 billion, this 2 represents 2 billion, and so on. Our x-axis here represents year, okay, so our year actually dates all the way back to 10,000 BC. And if you look, where the line is at this time, you'll see that the population of humans is well below 1 billion people in the year 10,000 BC. And it really stays well below 1 billion people for a very, very long time. For thousands of years, it stays well below 1 billion people until we reach 1880. 1880 is where the population finally reached a billion people. Now look and see what has happened since 1880. If you continue to follow the line, it just spikes upwards, right? Now, as you can tell, this is a pretty old graph because we see that 2015 is actually projected in this graph, but it still holds true because we know that the population is still exponentially growing, okay? So we can see ever since the 1800s, right, ever since 1880, the population has just been growing very, very, very quickly. Even though for thousands of years, our population never reached a billion people, was well below a billion people. But now our population almost every decade has gone up at least a billion people. All right? Now we're going to take a break for a second because I have a really, really, really tough question to ask you guys. And I'm giving you the warning right now that every time I talk about this with my students, They always pick the wrong answer. And in fact, every time I tell them what the right answer is, by the time the test comes around, they're still giving me the wrong answer. So this is just going to be a really tough question for you guys to grasp the idea of, okay? But I'm promising you that the answer I'm going to give you is the correct answer. So the question I have for you is, what has caused this increase in the population? Well, before we can talk about that question, let's review some stuff that we've talked about before. First of all, remember I gave you an equation for population change, right? Population change is equal to birth minus death, okay? So let's say, for example, in your population there were 100 newborns, 50 died. What's your population change? Should be plus 50, right? Because you do 100 minus 50, that's plus 50. So population change is equal to birth minus death. With that equation, if you have a greater amount of birth than you do death, then your population will increase, right? If you have less birth than death, meaning that death is greater than birth, your death rate or your death total is greater than your birth, then your population is going to decrease. If your birth rate and your death rate are the same, then you can expect your population to not really change at all. It's going to stay the same. So with that in mind, what has caused this increase? Well, in order to have an increase, we need to have this right here, birth being greater than death, right? So we now know that the birth rates are higher than our current death rates. But is this a scenario where our birth rates have increased, meaning that we're having more babies, we're having more children than we ever did before in the history of mankind? Or are the death rates dropping? Okay, are people living longer? Are they dying less? And the answer is B, that our death rates are dropping. Okay, hold on a sec. No fill, there we go. So our answer is B, that the death rates are dropping. We are having lower death rates. And I guarantee you, when I first asked this question, you thought, oh, it's obviously A, because higher birth means you have an increase. That's not the case here. All you need is for your birth rates to be higher than your death rates. Yes, birth can increase. That is a way for birth to be greater than death. But also you can have death decreasing, death rates decreasing in order for birth to be higher than death. In fact, our birth rates have actually slightly decreased in the past couple hundred years, okay? We are not having more babies than we did thousands of years ago. In fact, that birth rate is kind of less now, okay? But our death rates have definitely dropped within the past couple hundred years. And here's why. So again, the dramatic increase in Earth's human population has happened because of lower death rates, not higher birth rates. I need you guys to understand that concept, that the death rates have dropped. We are not having more babies. We are not having higher birth rates than we did thousands of years ago. Our population did not spike the way it has because of higher birth rates. It just did not happen like that. People are living longer. Death rates have declined. And we can kind of attribute to those death rates declining for a number of reasons, right? There's quite a few reasons out there as to why people are living longer. But here's a few for you to think about. First and foremost, death rates have declined mainly because of advancements in medicine, right? Like vaccines and things like that. So with more advanced medicines, we're able to fight off infections better. We're able to, you know, um, essentially live longer due to the fact that we have medicine, right? Second is adequate food. And I would argue that it's not just the idea that we have a good quantity of food, right? That we're able to get enough food to eat. But it's also the fact that we know what food we should be eating, right? we have better knowledge of what consists in a healthy diet. Okay. Number 3 is clean water. So we have technology now that allows us to clean our water, and that way we don't have to drink very polluted water. Okay. And our fourth main reason we're going to talk about is this idea of safe sewage, okay? So we have a sewage system that essentially takes all of our waste and takes it far away from our house. So we don't have to, have that stuff sitting in our house where all of our food and water are, okay? So again, there's other reasons as to why death rates are dropping, but these are the main four that I want you guys to think about going forward. Advancements in medicine, adequate food, clean water, safe sewage disposal. And with the decrease in our death rates, let's talk about life expectancy, because ultimately the reason that death rates are dropping is because life expectancy is increasing. Life expectancy is the average length of time that an individual is expected to live. Okay? So this isn't necessarily how long they're exactly going to live for, but it's an expectation, right? And if you take a look at the graph down below, you'll see that life expectancy over the years has been increasing for a while now, okay? And what you'll notice too is that you see there's 4 different lines on that graph. One says more developed regions, one says world, one says less developed regions, and then one says least developed regions, right? So those different lines sort of indicate different areas of the world that are more developed, meaning that they have more resources available to them that allow life expectancy to be higher, okay? Or you have these less developed regions where they really don't have those resources available that are going to keep their life expectancy high, okay? And that world one in the middle, that red line, is just sort of the average life expectancy found around the world, all right? So we're going to pause again because I have another question to ask you guys, all right? Is the human population growing at the same rate throughout the earth? For example, is the population of the US growing at the same rate as the population of India? And the answer for this is no. Um, Even though the world as a whole is growing exponentially, right? The human population of the world is exponentially growing. Different regions of the earth, right? Different countries of the earth are growing at different speeds. There are going to be some countries that are growing much faster, and then there's going to be other countries that aren't really growing much at all. In fact, there are even some countries that aren't growing, period. They're actually in a bit of a decline, okay? So, what I want you to understand now is the fact that, yes, the world's population is growing exponentially, but it's growing at different speeds all around the earth. All right? And now what I want to talk about is there a way to determine how fast a country's population is growing? And is there a way that we can predict how fast the population is going to grow in the future? And one major tool that allows us to do that is age structure. Age structure is the classification of members of a population into groups according to age. Now, with age structure, the groups that they normally use are really like technical groups that I'm not really going to get into. I just want to break it down in terms of younger people and older people. So for our age structure, we're essentially going to look at the ratio of younger people in our population to older people in our population, okay? It just makes the concept a lot easier that way. Well, how is it that we can use age structure, which, as I said, we're going to talk about the ratio of younger people to older people. How is it that we can use that in our process of determining how fast the population is going to grow? Well, going back to what we said before, population changes based off of birth and death, okay? and we can assign those to our age groups. I'm going to assign the birth part of our equation to our younger generations, right? Because in any population, right, in any human society, it's really our younger generations that are the ones that are responsible for giving birth. Usually, up through the age of like 40 to 45, you see people having kids, right? And even potentially as young as, let's say, like 15, okay? So we're going to label our younger generation or our younger people as those that are the ones that are responsible for birth. Now, for the death part of our equation, we're going to give that to our older generation. And I really don't mean to sound mean about that or, rude, but ultimately, for those who are, you know, roughly over the age of 45, they're not really having kids at that point. Or, I mean, not to say that you can't, but you don't necessarily see it as often, okay? Um, so if they're not going to be a part of our birth calculation, they're going to account for our death calculation, okay? So with that being said, remember, okay, population change is birth minus death. If you have more birth than death, your population is going to increase. If you have more death than birth, your population is going to decrease. And if your birth and death are the same, then your population is probably going to stay the same. So let's take a look. If you are a country that has high rates of growth, okay, meaning that you're growing at a really fast rate, that usually means that for your age structure, you usually have more young people than older people. In other words, your birth is going to be a lot higher than your death because you have more young people who are giving birth and less older people who are dying. Okay, so your birth to death ratio, your birth is going to be higher than your death. And with that, you get faster growth. Moving on, countries that have slow to no growth usually have an even distribution of ages in its population. In other words, this is a scenario where you can really expect your birth rates to be equal to your death rates, okay? And finally, countries that have a decrease in population usually have more older people than younger people, meaning that ultimately that country is going to experience a larger portion of death rates compared to birth rates, okay? So that's how we can use age structure to determine the rate at which a population is growing, is because by looking at the ratio of younger people to older people, we can use that information to decide, how the birth rates and death rates are impacting the population change in that population, okay? And like any data that we collect, we're able to put our age structure data into something called an age structure diagram. You might also sometimes hear this called a population pyramid, okay? Either name applies. And with an age structure diagram, you're essentially creating a graph that is symbolic of the ages in your population, okay? Age structure can be graphed in an age structure diagram, which is a type of double-sided bar graph. So let's take a look at our age structure diagrams down below. The one to the left represents France. The one to the right represents India. Let me explain how these population pyramids or these age structure diagrams are set up. The first thing that you'll notice is that there is a blue side and that there is a red side. With these age structure diagrams, they are usually broken down into the two genders, right? Male and female. All right. That's why it's a double-sided bar graph. It's because on one side of the age structure diagram, you are representing males. On the other side, you are representing females. All right. What you also might have noticed is down below the x-axis. So typically when we're making any kind of graph, you usually have that graph being read from left to right. Okay, your x-axis usually goes in some sort of direction from left to right. In this situation, we're starting in the middle because remember this is a double-sided bar graph. So we're starting in the middle and branching out to the left or to the right. Okay, because remember our males are being represented to the left, so we're starting in the middle and moving left, and our females are being represented on the right, so we're starting in the middle and moving to the right. All right. The last thing I want to point out is the y-axis, which is our ages. Now, if you notice, our ages in this are broken down into 5-year denominations, meaning that with any age structure, you're not usually graphing the individual ages because you don't want your population pyramid to go up, let's say 100, spaces. So in order to avoid that, we usually break down our ages into groups of 5, okay? And what that does is it allows the information to be a little more concise. It allows it to be a little more easy to read, okay? So if you notice, our population's ages are going up from 0 to 5, and then 5 to 10, and then 10 to 15, and so on and so forth, okay? Now, how is it that you read this age structure diagram? I just went over what the parts are of the age structure diagram. How is it that you read it? Well, for each age and for each gender, we are able to determine the percentage of that group within the total population. Okay, let's do an example. So I'm looking at France. Okay, looking at France, and I'm looking at males between the age of 0 and 5. So if I wanted to figure out what percentage of France's population is males between 0 to 5, what I would do is I would look at the left side of the graph, right, the male side. I would look at where our age group is 0 to 5, which is right here. So I'm going to follow this bar right here. This bar represents males between 0 to 5. I'm starting in the middle. I'm working my way left. And I stop right here, which is between 3 and 4. And I can estimate that to be around maybe a 3.7 or a 3.8. So what that tells us is that the percentage of males in France between the ages of 0 and 5 is about 3.8%. Okay? So 3.8% of the population of France is males between the ages of 0 and 5. Let's do another one. Let's look at females between the age of 65 to 70 in France. So here's my female side. I'm on the right side. I believe I said 65 to 70. So here's that age group. So I'm going to come over. Here's the bar we're looking at. Again, I'm starting in the middle, and I'm working my way to the right, which is to right here. That's about where it ends. And I'm going to figure out what percentage this line indicates, or this bar indicates. And this is going to be a little challenging because of just, the size of the picture. But it looks like, to my eyes, it looks like it's a little past 2, so it might be like a 2.2 or 2.3%. So in other words, 2.3% of the population of France is females between the age of 65 and 70. Okay? So that's how you read the age structure diagram. Now the last thing I want to point out is one more thing you might have noticed. If you look at France, the shape of that pyramid, the shape of that diagram is pretty narrow. Whereas if you look at India's population pyramid, their age structure, it's a lot more wider at the bottom. It looks a lot more like a traditional pyramid, whereas to the left it looks more kind of like a skyscraper, right? Now, that is a very important distinction because just by looking at the shape, we can actually determine how fast these populations are growing. In fact, I can tell you that India's population is growing at a much faster rate compared to France's population. Even though India's population, if you know this, their population pyramid ends right about here, whereas France goes all the way up here, okay? You might say, well, wait, France is growing faster. They got more at the top. It's not about what's at the top. It's about the shape that the graph is making. And based off of the shape, India's population is growing much faster compared to France's. And here's why. The shape of any age structure diagram will tell you how fast that population is growing. If you recall, India's looks very similar to this shape. Okay, it looked like more of a traditional pyramid with the very wide bottom, and as you moved up, it got very, very narrow. This shape indicates that you are experiencing rapid growth, okay? Why? Because you have a much, much larger percentage of your population being younger people. Remember, I told you in order to experience rapid growth, you have to have a larger number of younger people in your population compared to older people, okay? And remember, you're reading this from the bottom up. So at the bottom are your younger age groups, and as you move up, you experience older age groups. It's very clear here that the bottom of this pyramid is much larger than the top of this pyramid. Therefore, we can say that this population has many more younger people compared to older people. And when you have more younger people than older people, you are going to have a lot more birth than you will death. And if you have more birth than death, your population is going to increase. I know that was a lot. If you need to, you can rewind, listen to it again. But that is how I'm looking at that shape and able to tell that with that shape, you get a rapid population growth. Okay? Let's take a look at the next shape. This one here, the bottom, you can see is getting a little thinner compared to our rapid growth over here. So it's still thinner, but it's still a bigger portion down here than we have up here. Therefore, we can still say that we're experiencing growth. It's just slow growth. Why? Because the bottom half is only a little bit bigger than the top half. So we can say that there's more younger people than older people, but not by much. So we're experiencing more birth than death, but not by much. Okay? So with that, we get slow growth. This one over here, we have zero growth. Why? Because our bottom half is, I know it's not exactly the same as our top half, but it's close enough that we can pretty much say with this age structure that there's just as many younger people than there is older people. And with that, we're experiencing pretty much the same birth rates as death rates, okay? This one over here, we are experiencing negative growth. Oh, sorry about that. We are experiencing negative growth. Why? Because our younger population, the bottom half of this pyramid, is a little less compared to the top half of this pyramid, okay? So what that tells us is we have more older people in this population compared to younger people. And what that means is we are going to experience more death than birth. And with more death than birth, you get a decrease in the population. All right? All right, so that's the end of the notes. It's really, really important that you understand what these notes are telling you because there's a lot of valuable information in here that you're going to need in order to go forward and do the assignments that I have for you, okay? If you need to rewatch any of this, please do. If you need to ask me questions, please do. You can message me on Remind. You can email me. You can call that number I gave you. Any questions you might have about these notes, please make sure that you ask them, all right? All right. Until next time, talk to you.